Hi, everybody. Today we're going to do a lesson talking about something called a pendulum. So a pendulum is something that you can see sometimes in nature and in things in your life that might happen. So one of the ways that you might have seen a pendulum, if you've ever watched an old magician trying to hypnotize people, they'll hold a string and say, "Watch my magic," whatever it is, my pocket watch, right? So a pendulum basically means it's a heavy weight on a string that swings back and forth. Now, we're going to do a little bit of an experiment today, and I'm going to talk it through with you. But this is something that you can do at home if you have a few simple, I want to say ingredients, but supplies, okay? So the first thing I'm going to do is I'm going to take a little piece of string, and I'm going to cut my string. That way I can use it. Now, I'm cutting it a little long because I want to be able to use it for a few different pendulums, okay? Okay, so here's my long piece of string. The other thing that you need is a washer. So a washer is a big, heavy piece of metal. I mean, I don't have any washers here, so we're going to use a little binder clip. So I'm going to take my little binder clip, and now we're going to look at this pendulum. So it swings back and forth. What happens over time to the pendulum? Do you see it slowing down? Okay, so I'm going to keep this extra string right here. Let's look at it a little closer. Okay, so here's my pendulum. Notice that it's getting lower and lower and lower with each swing, right? That's how a pendulum works. What happens if I hold my pendulum closer? Oh my gosh, look how fast it's swinging. Again, eventually it slows down, so it's almost at a stop, right? What happens if I have a really long string? It takes a lot longer for it to go one swing back and forth, right? So we're going to use that idea today for our lesson. So we are going to be working in our Everyday Math Workbook, page number 311. All right, page 311. This is the page that we're going to be on. So it says a pendulum consists of an object called a bob suspended from a fixed support so that the bob can swing freely back and forth. You might have seen a pendulum clock. According to the legends, some Italian scientist Galileo began investigating pendulums since 1583. After he watched the hanging lamp swing back and forth at a cathedral in Pisa. So the Leaning Tower of Pisa, same place. Galileo discovered that each swing of the pendulum takes the same amount of time. So he began using pendulums as timing devices. Later, his findings led Dutch mathematician Christian Huygens to invent the first pendulum clock. Imagine that you have two pendulums, one longer than the other. Do you think the two pendulums would take the same amount of time to swing back and forth? Or do you think one will have a longer swing time than the other? Explain your answer. So think about what I just showed you. When I had the pendulum short, and then when I had the string really long. Did one of them go faster? What do you think would happen? Well, based on our video, or the first part of our video, I would say that the pendulum that is longer will take more time to swing back and forth because it has to travel farther. What that means is if my little pendulum is really short and it's going from back to forth, it goes from here to here. That's a short distance, right? But my long pendulum goes from here to here. That's a long distance. That's what I was trying to say. It is going to go a little bit slower because it has a longer distance to swing back and forth. Everyone look at page 312. we're going to do an experiment. So I'm going to demonstrate this a little bit with you with a pendulum that is 50 centimeters long. So 50 centimeters, almost a yardstick, almost a meter stick. So let me see. Did I cut it the right length? Let's see. Thought I did. 50 centimeters will be right here. Awesome. Okay, and I just want to make sure that I have this tight around so I don't lose my string. 50 centimeters. Okay. So what's going to happen is, this is the longest. This is 50 centimeters here. We're going to look at what would happen if my pendulum was 500 centimeters. I'm sorry, 5, 10, 20, 30, 40, and 50. And we're going to measure with our pendulum. So let's look at 5 centimeters. Let me make sure that I have my finger right at 5. Okay, I need to pull it just a little bit tighter. Okay, we need to see how long it takes to go 10 swings. So a pendulum swing is from one side to the other side and back. So 1, 2, does that make sense? So what's going to happen? I'm going to start my little stopwatch here. And we're going to see how long it takes. Are we ready? 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I didn't hit start. Dagnabbit. Ready? 1. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took right at 4.5 seconds. Now, what I'm going to do is I'm going to go ahead and fill in this chart the rest of the way. So I'm going to do this experiment. I am going to do it off camera just because I don't want to take the time doing it. I did want to show you what I mean when I say pendulum, using this to help us out measure. So 1, 2, 3, 4, 5, 6. You see how it goes slower as it gets longer, right? So I'm going to do this off camera, and I'm going to put your information and your data in this chart. So if you want to go ahead and do this experiment, go ahead and try it on your own. I am going to pause the video now. Try it on your own if you'd like. I'm going to use my data in just a moment. When you are ready, you may hit continue. All right, this is what I did. I went ahead and measured all of these swings. I want you to go ahead and fill in your chart. So at 5 centimeters, it took 4.5 seconds. 10 centimeters, it took 6.3 seconds. 20 centimeters, 9.0. 30 centimeters, 11.0. 50 centimeters, it took 14 seconds. 75 centimeters, it took 174 seconds. 100 centimeters, it took 20 seconds. And for 200 centimeters, it took 28.4 seconds. Take a moment and write that down. All right, now let's think about place value. We're going to do a quick way that you can actually divide by 10 to help you fill in this last column. I'm going to give you a little bit of a hint. Remember that when you divide by the 10, just like when you divide by powers of 10, you move the decimal 1 space to the what? Do I move my decimal to the right or to the left? When you divide, you're going to go to the left. Awesome. It says, why might it be more accurate for 10 swings to divide by 10 more than just one swing? Why is that more accurate? Well, if it took 4 seconds for the 5 centimeters, imagine, especially when it's really short, right? These really short ones. Imagine trying to time this. See how fast it goes? Pretty quick, right? So trying to measure one swing, especially with a shorter pendulum, is almost impossible. Okay? All right, move the decimal to the left one spot. So it's, I forgot to write it, sorry. Hard to time one swing because it is too short of a time. All right, here we go. Move one spot to the left, 0.45. I'm going to say that's close to 0.5. Move one spot to the left, 0.63, as I'm going to say 0.6. 0.9. 1.1. 1.4. 1.7. 2.0 and 2.8. Awesome. All right, here you go. This is your next question. Choose the ordered pairs. So you're going to look at the data from here. This is your X and this is your Y. It's per one swing. So write this as an ordered pair. So I will give you your first one. My first ordered pair would be 5, 0.5. My second one, I'll give you that one too, is 10 and 0.6. So on this paper, 10 and 0.6. I want you to write your ordered pairs. Make sure when you type it in this form that you have your commas and your parentheses. All right, these should be the ordered pairs that you came up with. 20, 9/10. 30, 1 and 1/10. 50, 1 and 4/10. 75, 1 and 7/10. 100, 2/10. And 200, 2 and 8/10. Now, your goal is to put it on the chart. I want you to take a moment. Make sure that your chart has all of these points listed, and then draw a line connecting them. After your chart is finished, you may hit continue. All right, after you are done, you should have your pendulum looking like this. I did use line segments to complete the points and connect them. What do you notice? What do you notice about how fast the points grow in here versus how fast they grow here? What is one thing that you notice about this graph? Well, I noticed that it kind of grew pretty quick here, right? And this was going a lot faster, right? And then as it got here, it started growing a little bit less. I noticed that it's not a same rate. It's not a constant rate the whole time, right? I also noticed that it swung a lot faster the smaller it was. But once you got a little bit higher, it didn't make that much of a difference. It did, but not a lot. If you have ever been to the Indiana State Museum, there is a pendulum that actually they use to tell time. And it's kind of neat because as it goes back and forth, it actually knocks down pegs that tells you what time of day it is, because the thing with the pendulum at the Indiana State Museum is instead of just swinging back and forth in one solid movement this way, it swings back and forth, but it also goes a little bit with the rotation of the earth. So basically it kind of goes in an elliptical pattern, kind of like this. So as the earth is spinning and as the earth is rotating, it knocks down the different hooks in different spots. So it kind of rotates with it. So if you've never been, that is something really cool to go see. All right, guys, I hope you enjoyed this pendulum lesson. Have a great day, and we will see you later.